All right. All right. So worked on it some more, and I got a solution. It's not a very good, elegant solution, but it's a solution. So on the second session, I figured out that the one way to count the number of ways to create the triplets is to get the number of ways to get a middle value and multiply the common elements before the middle value and the common elements after that middle value in both arrays. So um, so like if 0 is no element, then 4 could be the common. Um, there's one common number 4 that is before 0, and there's two common numbers, uh, values 2 and 3 after it. So there's two combinations of that, 1 times 2. In any case, I also created to make it easier on myself, I created a mapping of h number to its index, kind of, because if you do that mapping for both arrays, like once you basically make one array be 0 through n minus 1, and the other array be something based for that, the number of ways you can construct triplets is the same, but the triplets are a little easier to understand. In any case, I had a really hard time figuring out the number of ways to, even after making that adjustment, the number of ways of getting a particular number, the count of the number of ways that are common before a particular number. So for instance, if you have two arrays that are 0 through 15, so 16 elements, and then the other array is kind of this random stuff here. Like let's say you have 11. Well, you know that there's 0 through 10 as the number of values before 11 in your kind of baseline array, but how do you know which of those numbers, how many of those numbers are, how many of the 0 through 10 are before this 11? Well, I couldn't figure out a more elegant solution than basically a bunch of sorting, inserting, sorting again, finding indices. So for instance, if you start with an empty array and you have 11, you would insert 11 into the 0th element, the 0 index spot, and 0 also represents, or the index you insert also represents the number of values before this that are smaller than 11. So 0 is the common pre-values for 11. And then if you have 5, if you kind of insert it into 11, go into index 0, 0 represents the common number of values before 5 even throws, which is 0. 7 will get inserted into index 1, which means that there's one element, value 5, that's common both. 8 would get inserted into index 2, which means there's two elements, 5 and 7, that are common both. So in that case, you do that insertion sorting using bisect, and then you do a similar thing backwards to find the number of values after that are common. Like you go backwards through the array, and then you create a sorted version of the values that you've seen in the ending spots of the array, and then you calculate how many based on the insertion point, how many common values are after that. And then you just multiply the common values before and after. In any case, this ends up being very, very slow, as in orders of magnitude slow. Like 10 times as slow as the more optimized solution. But somehow it does beat it in memory. Alright, I've given up on trying to find a better answer for this. So I'm going to look at the fast solutions at this point. Alright, I don't understand that one. Good God, this is messy. What the fuck? What is all this stuff? Holy shit. Give me something simple, okay. Okay. You have position. You have a sorted list. Okay. Alright, it looks like they might have used a slightly faster. I'm not sure what sorted list is compared to list. They use bisect left. I use bisect left a couple times. So it looks like they are similar. I must be doing something slower though. I mean, I guess I'm using bisect left. Alright, I'm good with this. Like, it doesn't seem like it's worth the bother. But streak maintained. Are you sure? Or am I sure about what? Sorry. Just reading the chat. Am I sure? Well, I know the solution. Yeah, I don't know.